This is your introduction to geometry. Geometry is out of this world, and in fact, you learned about pretty much everything in this video in 3rd grade. In 3rd grade, you had to identify. In 4th grade, you need to be able to identify, define, and draw each of these geometric terms and shapes. As we go through this video, I suggest you pause and write down each term, the definition, and draw an example to help yourself learn about each of these geometric terms. I've had students in the past make like little books or make flashcards to help them study. There will also be a Quizlet at the end of this module to help you review all the terms because it's a lot, we know. Before we get started, let's have a little fun. You might try making a dot-to-dot about geometry. You might think a dot-to-dot was just for fun, but really it all has to do with geometry. So let's fly on to the next page and see what I mean. Each dot on a dot-to-dot picture is a point. This is a point. A point in math is defined as an exact location on a line, in a plane, or in a space. And on the page, when you see something in yellow, that would be the term here, and the definition is here. And then this is what you would draw. Each time you join 2 points, you create a line segment. So I have a point, and when I connect them, dot to dot, I have a line segment. If you make a fist with your left hand and you make a fist with your right hand and imagine a line going between each of those, that's a line segment. One fist for each point. Line segment. A line segment is a part of a line with 2 endpoints. Don't forget to write these down. Sometimes we must name points, otherwise we wouldn't know which points to connect with line segments. Imagine trying to complete a dot-to-dot if the points weren't named. You wouldn't know what to do, would you? You wouldn't know if you need to go A to C, A to B. So naming the line segments are important. Line segments are named according to the points. The cool thing is line segments can be named forward or backwards. So this is line segment KD or DK. You would write it as KD with a line on top or DK with a line on top. You don't have to draw the points when you're naming it. You are practically surrounded by line segments every day. They're everywhere. Can you find and highlight some of the line segments in these items? So if you pause the video and you found some line segments, let's see if you can find the same ones I did. Ooh, it's a very large highlight. You can find one here. These are line segments. This is a line segment. This is a line segment. Each fry could be a line segment. The side of the milk carton. The roof on the house. The side of the present. There's tons of line segments. Let's buzz on over to the closest star to Earth, the Sun, and learn about something else. From the Earth, the Sun looks more like this. Okay, so it's a cartoon picture, but you get my point, right? Rays of sunshine shoot out from all directions from the Sun, warming us with radiation and giving us light. In math, a ray is similar to a line segment, with one exception. A ray is similar to a line segment in that it begins at a point, so that's the Sun. But instead of ending at another point, it continues through other points on into infinity. And I always remember that there are many points on this line that we don't write or show. But all those points are connected. An array has one endpoint, and then it continues on and on and on and on and on in one direction, just like the Sun. Remember to record your term and definition. A ray is named by the points through which it travels, but since it travels only one direction, it can only be named in one direction. So this is ray AB, or I could say AB with a ray on top of it, but I don't draw the endpoint when I'm naming it. And this is ray DC, or DC with the ray on top. Notice that even though it's pointing to the left, I don't call this ray CD because I name it by whichever the endpoint is goes first. In math, a true line is like a ray, except it continues in both directions to infinity. So instead of having a starting point like the sun, it goes on and forever in both directions, like a number line. And then these are made of many points on this line that we don't see. When we name them, we draw 2 points. We don't put the letters by the arrows. We put them on points on the line. So a line continues in both directions. Since a line travels in both directions, it can be named by its points going either way. This is line AB or line BA. You could also say that it's AB or BA. Notice when we do a line, when we name the line, we do put the arrows, but no points when we're naming it. Rays, lines, and line segments can sometimes intersect or cross each other. Like line AB is crossing line BC, ray BC, and line segment CD is crossing ray BC. If lines, line segments, and rays never intersect, they could be parallel to each other. They're the same distance apart. They are side by side, yet the same distance apart, no matter where you are on the line. Kind of looks like railroad tracks. And the sign for this, for parallel, is when you have these two signs. Notice, these are not the same distance apart. They cross each other here, they cross here, so anytime they touch is intersecting. If they never touch, they're parallel. And always helps me remember, look, parallel has 2 L's in it that are, an L should be parallel. You don't want them to cross. So let's look at this example. Ray BA here is parallel to ray CD here. They never touch. They are the same distance apart. Now, line segment BC does touch them, but we're just talking about the ray BA and ray CD. One more thing, when lines, line segments, or rays intersect, an angle is created. Not an angel, an angle. Be careful of that spelling. So there are 3 types of angles. A right angle, also known as a 90-degree angle, or a square angle. Draw a little square in the corner of a right angle to show that it should be exactly square like the edge, the corner of your paper. An obtuse angle is greater than 90 degrees, like a fat angle. It's bigger. 90 degrees would be here, and it goes past that. An acute angle is less than 90 degrees, like a skinny angle. We go, oh, look at the little cute angle. So here's a 90-degree angle, and any acute angle should be able to fit inside of it. Lines are said to be perpendicular if they intersect at 90-degree angles. So if they make a perfect right angle, then they're perpendicular. So line AM and line CD are perpendicular. AM and CD. Pretty cool. See if you can find any right angles, obtuse angles, or acute angles in these things. And you can highlight or think in your head the angles that you identified. You may pause the video. So if you found some angles, let's see. This is acute. I'll try a different color. This is obtuse, acute. Oh, look, inside the spider web, that's acute. This is acute. Obtuse on the clock. Ooh, this is an acute angle. This beak's acute. These are right angles. And the corner of this pizza is acute. Polygons. Polygons must have sides that are straight, and it must be a closed figure. These are polygons. These are not polygons. These circles do not have straight sides. And this is not closed. If I made a line here and closed it, then it would be a polygon. A triangle has 3 sides. A quadrilateral has 4 sides. And a pentagon has 5 sides. There we go. Triangle has 3 sides. Quadrilateral has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. And an octagon, like a stop sign, has 8 sides. So make sure you can write and draw each of those types of shapes. So you want to put triangle, then the definition is 3-sided polygon, and then draw a triangle. And if you need to go back, you may. Now let's focus on just quadrilaterals. A quadrilateral is a polygon with 4 sides and 4 angles. On this video, you see all these quadrilaterals. Some quadrilaterals have special qualities and are given special names. Each has different features, and some can be classified in more than one way, meaning they might have more than one name. So what are quadrilaterals? You will see a video in the module next that is really funny about Math Mansion and a guy with a funny accent explaining quadrilaterals, so be sure to check that out. First, there are trapezoids. What do you notice about these trapezoids? Well, if you notice that only one pair of parallel sides, that is what a trapezoid is. So it can be the top and the bottom, like this, top and bottom are parallel, or it can be, I can turn it and it can be the sides. All these are facing one direction. Let's turn this one. So this is a trapezoid too. It has those sides parallel. As long as one pair of parallel sides, then it is a trapezoid. A parallelogram. What do you notice about these quadrilaterals? Parallelograms, if you notice, they have 2 pairs of parallel sides, and the opposite sides are congruent. Congruent means same size, same shape. So these 2 sides are parallel and they're congruent. They're the same length on each side. And also the top and the bottom are parallel and congruent. So parallelograms have to have both 2 pairs of parallel sides, where a trapezoid only has to have 1. Then the other sides can be slanted, or like it has this right angle here, and you think, oh, that could be a rectangle, but it's not because this side is slanted. Make sure you're drawing each of these quadrilaterals. A rhombus, what do you notice about these? This has 2 pairs of parallel sides and 4 congruent sides. So a rhombus is a special type of parallelogram because it has opposite sides parallel, meaning they never touch and are the same length. But rhombuses are special because every single side of a rhombus is the same length. And I put lines on each of those to show, one line through each, that they are all the same. On a parallelogram, I might put one line here to show those opposite sides are parallel, and put 2 lines on each of those sides to show that the top and the bottom are congruent to each other, and the one with one line on each side is congruent to each other. So a rhombus, all the sides have to be equal. Rectangles, what do you notice about those? Well, if you said, it's kind of like a parallelogram, you are right. It has 2 pairs of parallel sides. It is a special type of parallelogram. So it has opposite sides parallel that don't touch and are congruent, the same length. But it's not a rhombus. It doesn't have to have all sides the same. But it does have to have 4 right angles. So every side that touches each other, makes a corner, should be right angles, perpendicular. So 2 pairs of perpendicular lines on each side. Now, what do you notice about a square? A square, the definition, it is very special. It has 2 pairs of parallel sides. So it's a parallelogram. But it also has 4 congruent sides. All the sides have to be equal, just like a rhombus. And it has to have 4